Today's June 9th in the year 2010. I'm Karen Herman at the Archive of American Television. It's my great pleasure today to be interviewing Linda Ellerby here at her offices in New York City. Okay, we're going to end with... Okay, well, thank you so much, Linda. It's a pleasure to be interviewing you today. And we're going to start right from the beginning. What was your name at birth?
Linda Jane Smith.
Imagine migrating 200 hours of videotape, only to discover that, unbeknownst to you, corruption has plagued portions of several tapes. The videos looked fine, and your quality assurance process has been proven successful over 2 decades of use. What could have happened? Well, it turns out that HDV migration presents challenges unparalleled by other formats, and despite the tiny form factor of the tapes, can present monstrous hurdles that can stand in the way of preservation. Over the next few minutes, we'll talk you through our HDV migration journey, recounting the steps and missteps that resulted in a year-long experimentation and refinement period for our HDV migration process. I'm Nick Camardo, Digital Imaging and Content Manager at the USC Digital Repository. I manage technical operations for the USC Digital Repository and oversee a staff of video archivists and student assistants who work with high-quantity magnetic tape and motion picture film collections.
Hi everyone, my name is Alan Young. I'm a video archivist and a post-production specialist from USC Digital Repository. I started my career at USC 4.5 years ago. Prior to joining USC, I worked at an electronic service provider about 20 years, specializing in post-production electronic equipment, machine repairing, and maintenance. In my current position at USC, my main duties include overseeing the collection, management and transfer area of broadcast video equipment, troubleshooting software and hardware issues for tape migration, and perform DAC maintenance.
The USC Digital Repository is housed at the USC Libraries on USC's University Park campus near downtown Los Angeles. The Digital Repository is the result of a collaborative effort between the USC Shoah Foundation, Information Technology Services, and the libraries. The Digital Repository, or DR as it's known locally, provides digitization and digital preservation services both internally to the USC community and to external community partners and clients. The DR houses an automated tape storage system that holds over 80 petabytes of data mirrored off-site to provide continuous data monitoring and integrity. The DR has been working with the Television Academy Foundation since 2021 to digitize and preserve the interviews collection consisting of oral histories captured on Beta SP and MiniDV tapes. When the interviews team at the Television Academy Foundation and the DR first started working together, the project objectives were clear. Capture lossless versions of each interview and preserve them on the DR's preservation storage infrastructure. Our most commonly provided service is to digitize analog and digital videotape, storing them as losslessly compressed JPEG 2000 MXF files. For almost all digitization projects, we use several of our 24 broadcast-grade encoders to capture uncompressed SDI or HDSDI signals to provide for a mostly format-agnostic digitization environment. Our lab is wired to a 72 by 72 video router to allow easy switching between formats and provide the ability to digitize multiple projects simultaneously. In keeping with best practices in the audiovisual preservation field, the interviews team requested that the HDV tapes were migrated over FireWire connection. This is common practice for DV tapes. We all know and love DV Rescue. It seemed like a simple ask, and we were happy to adapt our workflows to accommodate. What we quickly learned was that the HDV format was just out of scope for the funding that supported the development of DV Rescue. We tried every permutation of FireWire capture imaginable, from vRecord to FFmpeg to Final Cut Pro to legacy software packages from Apple from back in the OS X Tiger days. Unfortunately, none of these checked all of the boxes for us. We needed something that provided the files in the MPEG-2 transport stream format, which is the native HDV file format, including any other accompanying data. We also needed a solution that was scalable and reliable. We were working with approximately 200 one-hour tapes, but this was just the beginning of several more batches of media. Finally, in a last-ditch effort, after scrubbing every online forum known to human, we landed on dvgrab. This is a long unsupported command line utility that runs on Linux and does exactly what its name implies, grabs DV data. The detail that put dvgrab in the lead was the simple fact that it could pull .dv files from standard definition tapes and .m2t, or the beloved MPEG-2 transport stream files from high-definition DV tapes. Before proceeding down the workflow implementation rabbit hole, let's zoom out and consider some of the technical intricacies of the HDV format.
HDV DV was one of the most popular machines used in the early 2000s due to its cost effectiveness and its ability to do FireWire and HD SDI output at the same time. Here's some interesting information about HDV specification that I would like to share. It was introduced in the 2000 by JVC, was supported by Sony, Canon, and Sharp. HDV are either in 720p or 1080i video and audio format encoded in digital forms. Using lossy interframe compression, the video format is encoded with H.262 MPEG-2 Part 2 compression scheme, using 8-bit chroma and luma at 420 chroma subsampling. The compression audio and video are multiplexed in an MPEG-2 transport stream. The resolution for 720p is at 1280 by 720 square pixel, 16 by 9, and for 1080i it's at 1440 by 1080 using a rectangular pixel stretch to a 16 by 9. It also shares the same infrastructure as DV. The HDV format uses the same track pitch and tape speed as DV formats and uses the same tape stock. Both formats use a recording data rate at 25 megabits for recordings. This technology has started to fade out during the past decade, and manufacturer has started to move on to a newer and more advanced technology in the recent years.
From there, it seemed simple. Migrate each tape to a single M2T file, create derivative access files, perform our standardized quality control process, and then ingest to preservation storage. To support a collection of this size, our first order of business was to build up infrastructure. We took 4 decommissioned super microservers from our reserves, outfitted them with 10 gigabit Ethernet cards, StarTech 3-port FireWire expansion cards, and a fresh install of Ubuntu. We relied on our bank of Sony HVR 1500s, which we have returned to time and again for their workhorse build quality and technical superiority, which Alan will revisit soon, and set up 4 migration stations, connecting 1 deck to each server and running 1 instance of dvgrab on each. Files were captured locally to a 2 terabyte disk cache and then copied nightly over to a networked storage cache for our QC and ingest processes. Everything went fine until it didn't. So what happened? The interviews team, in reviewing their videos, which had already been digitized, preserved, and made available on our online asset management system, found some segments of interviews in which the audio and video appeared to be out of sync. How could this happen? What you'll realize over the next few minutes is that I got pretty good at troubleshooting during this process, and my strategy harkens back to something we all probably learned about in middle school, the scientific method. One of the key takeaways from this project has been that by breaking down complex problems into their component parts, controlling everything except for one variable, and then testing and retesting, you can troubleshoot just about anything. You can hypothesize and test, but the key is to only change one variable at a time. Sometimes testing variables comes in the form of problem replication. Can we repeat the problem? If yes, change one variable, rinse and repeat. So the first question was, could it be the web player? I downloaded the file in question and played it with trusty old VLC. No issue. Go back to our web player. Also no issue. What the heck? Maybe it was the proxy file played in the web player. Nope, also no issue. Let's go back to the control, the original video, and try one more thing, ffplay. And there it was, corrupt packets. How could we have missed this? This is where things got pretty interesting. What you'll notice about these M2T files is that they look fine if you bounce around to different portions of the video. However, things go off the rails when you play through the corrupt frames. It's during these corrupt frames that audio and video fall out of sync.
Well, no, she just had a smart agent. Like, she had a smart agent. I think if my agent would have done the same thing. I was brand new, though. She was a movie star. Wouldn't you? I would. In this day and age, I think you would.
If you pause the video, move past the corrupt frames, and then resume playback, everything returns back to normal.
And you don't have to explain it either, do you? I mean, they know who you're talking about. It's fascinating, isn't it? And I don't
Now,
think it went on.
considering this in combination with our standard QC process, which is to spot check videos, you'll quickly realize that this was like finding a needle in a haystack. For a video with lots of corruption, the audio video would appear badly out of sync, and the tape would be sent back to our lab for remigration. In instances where the corruption occurs in only a few packets midway through the video, this became like finding a needle in a haystack. Since FFplay was able to call out the corrupt packets during playback, I realized that FFmpeg would be my friend in terms of evaluating the scale of the issue. I recalled the first batch of media from our preservation storage and scrambled together a quick FFmpeg script to decode the videos and pipe the output to text files. It was then a matter of looking through some of these text files for occurrences of that dreaded line, packet corrupt. What I noticed was that a lot of files had corrupt packets. Could these all have out-of-sync video? If that was the case, I was prepared to seriously revamp our quality control process. I spent a Saturday watching M2T files and noticed that corrupt packets were very common at the beginning and end of tapes. And again, whenever there was a break in recording, there was a chance for a corrupt packet. Not all of these, however, manifested in out-of-sync audio and video. What we could conclude at this point was that there was no reliable way to flag parts of the collection for remigration with enough certainty to ensure that we caught and remedied all instances of the issue. We decided that the most reasonable solution was to revisit the migration workflow, sort out the issues, and try again.
During the troubleshooting, we noticed that package corruption could be recorded into a tape, or could it be produced by a DAC in need of maintenance. Because of that, we need to make sure we choose the correct machines for the job. As an archivist at USC, one of our goals is to help Television Academy Foundation figure out the best practice to preserve media content. We do this by choosing the right machines for the tape capture. There are several HDV playback options, but we decided on Sony HVR 1500A for a few reasons. Multi-format DV playback, it has a built-in down conversion capability that allows 1080i recordings to be output as 480i and 576i signals from the iLink and SD-SDI interface. Rewind speed are an impressive 85 times normal playback speed. The mechanical playback response is much quicker than the consumer model. The cassette compartment is more robust and can handle much better than the consumer model. It uses direct motor drive, whereas the consumer model does not. It provides better electrical circuitry. It's a lot easier to clean.
Let's take a look at the professional and consumer decks. Alan will deconstruct the decks and describe how vastly different the mechanics and basic maintenance procedures are.
So this is a consumer deck here. This is a HVR 35MU. And right over here we have a HVR 1500, which is a professional series for the HDV machines. This one is obviously it's very hard to see what's inside and very hard to, unjam tapes. Okay. Oh, I already have here is just a consumer HDV deck here. What you see here is not as robust as what we have for the professional series. It's a lot harder to, unjam tapes, to clean the machines, to check for anything that is broken inside. For me to, clean this deck, it would usually take me about 25 to 30 minutes because of, taking out the whole chassis, and then after that we would have to, unbolt everything and take out the cassette compartment, and then take out a drum cover in order to just clean the drums. Now we have a professional series, HVR 1500 for doing HDV and DV and also DVC Pro. So now I'm just going to open up the machine and show you what it's like inside of a professional machine. Show you inside of the professional series machine. Sorry, it's a little harder. So in here, look, you can see, everything in here is much more open than what we have in the consumer series. It's a lot easier to take apart. It's much more open, and with 2 screws and 1 bracket, we can pretty much take out the whole cassette compartment out from the machine. Sorry. Just like that. and it only takes less than 30 seconds just to remove a cassette compartment. And you can, even without removing the cassette compartment, we would still be able to clean the heads without doing that. Yeah, right here. So same thing, what we do is we have a wet claw here, you know, and just gently press against the head. We rotate it around. And also this one has, you know, a better built-in head cleaner assembly that cleans out the head every time when you put in a cassette. So it cleans the head first once before it, you know. Yeah, you can see it. Right? We can clean out more.
A little bit like more this way.
Okay.
Yeah.
Yeah, you can clean more, you know, debris surface out from it more than what you can over on the consumer deck. As same thing. Same thing. I'm going to use another section and go back a couple of times. You can clean the lower drum, and the lower drum, same thing, you know, it's much easier to clean because you can rotate around the head. So much easier. It's one simple process. You put this back in there. I know it's harder to do it this way because I'm on the other side. So there's two little, you know, there's two little bumps right here that holds it down, just like that. And then we put this bracket back in. And these are the two holes that, you know, to hold down the housing. And then we put two screw backs on here. And put this back in. Just like that. In reviewing problematic tapes, we discovered that reasons we had never previously encountered this problem is that the HDSDI output of the DAC utilized an air concealment process that effectively hide corruption during playback. Given that we decided our approach was to capture tapes using both HDSDI firewire simultaneously, luckily, the HVR 1500 supports this feature. So we send the firewire signal to a server running DV grabs and the HDSDI signal to our video encoding server. This allows us to capture the raw M2T data to one device and the air concealment HDSDI signal to another device with only one playback of the tape, reducing the strain put onto the physical media. No, when using an HDV machine with lower drum hours, it's more likely to have a better outcome concealing error during playback in HDSDI, whereas using firewire would still create an outstanding audio and delay during playback when certain sections of the tape have corrupted frames. By using this simultaneous approach, Television Academy Foundation can have the flexibility to select either HDSDI or firewire format to fit different purpose and need. In a moment, we are going to provide an example of concealment error in HDSDI format and another example of out-sync audio problems for firewire. You'll see how HDSDI can conceal the problems on the tape.
Well, no, she just had a smart agent. Like, she just had a smart agent. I think if my agent would have done the same thing. I was brand new, though. She was a movie star. Wouldn't you? I would. Give her that billing? I would. In this day and age, I think. In this day and age, I think you
And
would.
how do you feel about the question that lingers on every man's lips ever since Gilligan's Island came on the air, that anywhere in the world you can go to someone and say, Ginger or Marianne?
And you don't have to explain it. And you don't have to explain it. I mean, they know who you're talking about. I mean, they know who you're talking about. It's fascinating. And I don't think it went on. And I don't think it went on during the show. I think it grew.
What we've come to understand is that packet corruption is inevitable when dealing with HDV tapes. The question then lies in whether or not the problem exists on the source tape or is caused by the playback infrastructure. As we've seen, dirty heads can result in corruption, but as anyone who's spent time with videotape knows, some tapes just like some decks better than others. Ellen has described how alignment and calibration can factor into this, and it might be the difference between 2 corrupt packets and 3. We are doing our best to find problems and fix as many as we can, and we're confident that this workflow will result in the highest success rate that we can achieve given the circumstances and intricacies of the format.